Okay, in this video I'm going to go through tips for balancing equations. There's no perfect way to get it right every time, but these are just kind of some of the tips you can use to solve these a little faster. So just to kind of intro what balancing equations are, here's just an example of an equation. This is actually a famous equation in chemistry. H2 plus N2 yields NH3. This NH3 is very important for fertilizer, and it was this process, which is called the Haber process, that was able to kind of really beef up the world's production of fertilizer, which kind of led to the population boom. This was like the early 1900s. Without this formula, the world would probably still be at 1 to 2 billion people. It was because of this that allowed such a population boom, because this fertilizer allowed for a lot more crops. Anyway, you can see that we don't really follow the law of conservation of mass right now, because I have 2 hydrogens and 2 nitrogens turning into 1 nitrogen and 3 hydrogens. So what we do is we put numbers in front to balance it out. You can't just change these numbers. These are called the subscripts, the 3 and the 1. Now, there is no 1, but if you see it by itself, it means 1. I can't just say, well, let me just change that to 2 and 2. You can't do that. You put coefficients in front to change it. So here I'm seeing, let's see, 2 nitrogens, 1 nitrogen, so let me put a 2 here, 2 in front of this, so nitrogens are now balanced. But now you can see I have 2 times 3 is 6 hydrogens, so I need a number here. Well, since that's a 2, I'm going to put a 3 there. So it's 3, 1, 2. If it's a 1, you don't put a 1. You just leave it blank. And now you can see this is balanced. Okay, so just to reinforce these terms, these are called subscripts. You can't change those. These are called coefficients, the numbers in front. Those are what you can change. And this arrow here means yields or produces. Yields is kind of the most common way. So you would say 3 hydrogen gas molecules plus 1 nitrogen molecule yields 2 NH3, which is called ammonia. All right, so let's go through the tips. And again, this is not the perfect way to get it right every time. You just can't do that. There's always going to be some trial and error. All right, so the first tip is to use a pencil. You'll be erasing a lot. I always suggest you bring a pencil during the balancing equations, because, like I said, you're going to be erasing a lot. Step 2, save lone elements for last. Lone elements for last. So just as a quick example, this shows the breakdown of hydrogen peroxide, the decomposition. If you have that brown bottle of hydrogen peroxide, you'll probably notice it has an expiration date on it. And that's because this happens naturally. It will break down into water plus O2 gas. So if you have an old bottle of hydrogen peroxide from 5-10 years ago, you probably just have a bottle of water. It usually lasts 1 year. By the way, that's also why it's in a brown bottle, because light speeds up this process. If you have it in a clear bottle or a plastic bottle, it's going to happen a lot faster. But anyway, you can see we're not balanced because I have 2 oxygens and 3 oxygens. So my tip is to kind of leave the O2 for last, because it's kind of a lone element. It's just the oxygen. Well, in this case, you notice the H's are actually already balanced, so I guess we're going to start with the O's. So I see 2 here and I see 3 there. So what I'm going to do is, let's see, I'm looking for an even number because that's going to be O2. So let me put a 2 here. All right, so now my O's are balanced. And, well, they're even on this side. Now I have 2 over here, so let me put a 2 here. And that should balance out everything, it looks like. So 2 times 2 is 4 hydrogens. Oh, we're not yet balanced. What am I doing wrong here? Okay, 2 times 2 is 4. But we are balanced. Okay. So you can see with the 2, and the 1, we're now balanced with the H2O2. Okay. My next tip is to keep polyatomic ions together. So you should recognize your polyatomic ions from that sheet. And instead of breaking them down into individual elements, you should try to keep them together. So let me start with this example here. So we have K's, we have N's, we have O's, we have H's, and we have C's, and more O's. This would be very complicated if we were to break all of that down into the N's and O's and C's. The easiest way to do this is to say, well, I have potassium, I have nitrate, I have hydrogen, and I have carbonate. Okay, 4 terms instead of 5. And over here, potassium, carbonate, hydrogen, nitrate, the same 4 terms. So keep those together. So anyway, when I'm balancing these, let's see. I'm seeing 1 potassium, 2 potassiums. So let me put a 2 here. Okay. 2 nitrates, 1 nitrate. So let me put a 2 here. Okay. 2 hydrogens, 2 hydrogens works. 1 carbonate, 1 carbonate, this works. So we have a 2, 1, 1, 2 balanced equation, and it's simple if you keep those polyatomics together. Okay. For combustion reactions. Now before I talk about this, let me go over what combustion reactions actually are. Combustion reactions. So you start with something called a hydrocarbon. Now, a hydrocarbon is basically, it's an organic molecule, meaning it's kind of a carbon-based molecule that consists of mostly 2 elements, obviously hydrogen and carbon. So the simplest hydrocarbon is methane, CH4. That's the gas that comes out of the Bunsen burner lines, CH4. But you can have all sorts of types of hydrocarbons. You can add another carbon and 2 more hydrogens. You can get C2H6. That's called ethane. You can get propane, C3H, I believe, yeah, it's 8, C3H8. But it doesn't have to be this neat order. You can have other elements mixed in there too. For example, most types of sugar. Sugars are hydrocarbons as well, just with oxygen mixed in too. So C6H12O6. So there's all a variety of hydrocarbons. Hydrocarbons are, most things that make up food. It's coal, oil, natural gas. So anyway, it's some form of hydrocarbon, which is mostly carbon and hydrogen, occasionally with other elements mixed in, like oxygen or nitrogen or phosphorus or sulfur, sometimes mixed in, plus O2, because you're basically burning it. And it's going to create 2 things. It's going to create CO2 and H2O. CO2 plus H2O. Okay, and this CO2 production, that's kind of what leads to climate change, because for 150 years humans have been burning an enormous amount of hydrocarbons, coal, oil, natural gas, and every time we burn it, it releases CO2 into the atmosphere. So that's where that extra CO2 has come from, or at least that's where a lot of what we call anthropogenic, the man-made CO2 comes from. All right, so anyway, when you balance these, there's a few tips. And the reason I'm singling these out, they are a little tricky. Sometimes these are very simple, but sometimes they get really tricky. So here are some of my tips for those. H, then C, then O. Is this a perfect way to do it? No, but it's just the easiest way that I've found to do it. Start with H, then C, then O. Definitely want to leave O for last. I mean, if anything, you could swap those first 2 and do O last. And the reason you want to leave O last, you'll notice it's by itself. O2 is by itself over here. So you want to leave O for last. Next, consider evens and odds. Here's what I mean by that. Notice, let me erase this just so we can see more clearly. Consider evens and odds. Notice I have O2. I don't have any O here, so my only oxygen is in the form of O2. What that means is I'm always going to have an even number of O's on this side, because I can only ever have multiples of 2 on this side. So that's what I mean. And you'll notice right now I have O2 plus O, so I have 3. So that's an odd number. And really, I'm going to need an even number in front of this, because I can't have an odd number, which would give me an odd number of O's over here, which can't be replicated over here. So that's what I mean by consider evens and odds. And finally, when in doubt, double everything. And you'll see a couple examples where I go through that. So let's start with this simple example. This is the simplest hydrocarbon. Shouldn't be too difficult to balance out. So my first step, H, then C, then O. Well, I have 4 H's here and 2 H's here. So I want to put a 2 there, but what I'm going to think is, by putting a 2 there, am I going to mess up my odds and evens? Well, if I have a 2, that's going to give me 2 O's plus another 2, so that's fine. So I'm going to put a 2 there. Okay, then C, H, then C, then O. So for carbons, 1 and 1, that's already balanced. And finally, my O's. Now, as long as I have an even number of O's over here, and my C's and H's are balanced, I'm in good shape. You just got to do the math. So 2 oxygens, 2 oxygens, 2. So 4 plus 2 times 2. So that's very simple, but there are more complicated examples. Let's go through a couple. So here are 2 examples here. This is C2H6. So this would be ethane. This one is hexane, just based on the number of carbons there. So let's do this top example first. All right, so H, then C, then O. So H6. Well, if I am balancing my H's, I would put a 3 here. But notice, if I put a 3 there, it's going to mess up my evens and odds. Because I'm now going to have 2 plus 3 O's, which is 5. And I can't have 5 O's over here because I can only ever have an even number. I can never get 5 O's over here. So when in doubt, double everything. Instead of 1 and 3, I'm going to double this to 6. Come on. Come on. I'm going to double that to 6. So that gives me 12 hydrogens. So here I'm going to put a 2 and double that. So now I have 12 hydrogens here, 12 hydrogens here, and I have an even number of O's, which is important over here. Now my carbons, well, 4. So I'm going to put a 4 there. That's still fine with my evens and odds. And now I just do the math on the O's. So 4 times 2 is 8. 8 oxygens here plus 6 oxygens there is 14. So I need 14 O's. So the number I'm going to put in front of here is a 7. And we're balanced. Okay. Down here, C6H14. Well, 14 H's. So I have 2 here, so I'm thinking 7. But even before I write the 7, I'm looking ahead and I'm saying, if I put a 7 there, that's going to mess up my O's because I need an even number of O's. So instead of putting a 7 and getting an odd number, I'm going to double everything. And I'm going to put a 14 here. I'm going to put a 14 there. So that's going to give me 28 hydrogens. So I'm going to put a 2 here. So 2 times 14 is 28 hydrogens. 14 times 2 is 28 hydrogens. And now I have an even number of O's. Now let's do my carbons. 2 times 6 is 12. So let me put a 12 here. Still good on my O's. And now I do the math for the oxygens. So 12 times 2 is 24. Plus 14. So 24 plus 14, that's my oxygens. This gives me 38 oxygens. So I need 38 over here, 38 over here, so half of that's going to be 19, and that's going to go right there. So 2, 19, 12, 14. All right, back to the list. Now this step's a very rare one, but you'll see it every now and then it's going to show up and it's going to be very helpful. So if you see hydroxide, hydroxide is one of the polyatomics. It's OH minus. Okay? So you're not going to see OH minus, but you might see something like barium hydroxide, which is going to look like this. Or you might see potassium hydroxide, which is going to look like that. So if you see the OH polyatomic ion on one side and water on the other, meaning not hydroxide, like if you see barium hydroxide on one side and potassium hydroxide on the other, that's fine, leave it as hydroxide. But if you don't see the hydroxide on the other side, but instead you see water, here's what you want to do. Call the water HOH. Instead of H2O, call it HOH. And this is useful because now you don't have to break the hydroxide down into O and H. It's very annoying and it's going to take you more time. So here's an example. H2SO4 plus KOH yields K2SO4 plus H2O. This is called an acid-base neutralization reaction. H2SO4, that's an acid. KOH is a base. You mix them together. The acid and the base both cancel each other out. They form K2SO4, which is just a type of salt, plus water. So we call it a neutralization reaction. The acid and the base neutralize one another, and they form salt plus water. All right, so in this case, I see the OH on the left, but I don't see OH on the right. So what I'm going to do is change the H2O to HOH, like this. And now you can see I have hydrogen in the front, hydrogen in the front, sulfate ion, potassium ion, hydroxide ion, and it's a lot easier to balance. So let's go through it real quick. Well, 2 front hydrogens here, 1 front hydrogen here, so let me put a 2 in front. Okay, that gives me 2 hydroxides, so I need 2 hydroxides, so let me put a 2 there. That gives me 2 potassiums, we're good. 1 sulfate, we're good. So the numbers are 1, 2, 1, 2. And really what you want to do here is kind of erase this and just put it back the way it was, Because to express water as H bonded to hydroxide is wrong. Water is definitely not ionic, like that's implying. So I would cross that out and then just write the 2 down below. That's how you should write this equation. Okay? And my last and final tip, when you finish, make sure the numbers can't be simplified. It's definitely possible that you kind of make a mistake and kind of overshoot the correct answer. Like on this one, you may have come up with something like this. Instead of 2, 2, and 1, you could have come up with 4, 4, and 2, which technically isn't wrong. It's still balanced in the right proportion, but this is not the way we write it. You always need to write the simplest version of it. So if you see the numbers and you notice that they can be simplified, you have to do that. So instead of 4, 4, and 2, you can recognize, oh, those are all even numbers. You can simplify that down to 2, and 1. So that's the last step you always want to do. Consider if it can be simplified down. Okay? So these are my tips, 6 tips for balancing equations. So I have a bunch of examples right here. Sorry if it's kind of small, but pause the video, try to work through these, and then unpause it, and I'll sort of go through them. Okay, so for the first one, MgO yields Mg plus O2. So in this case, I'm going to leave the Mg for last because that's kind of my, it's sort of the lone one. And actually, I noticed the Mg's are already balanced. So for O2, I'm going to need 2 O's, okay? And now that gives me 2 Mg's, 1 Mg, so a 2 there. So that's just like a simple warm-up problem. That's kind of one of the easiest ones you'll ever see. Next one, C2H4 plus O2, so that's a combustion reaction. So my tip for combustion reaction, H, then C, then O. So for H's, H4, H2, so let me put a 2 there, and I'm thinking ahead, the 2, is that going to mess me up? No, that's fine. That gives me an even number of O's, so I'm fine. Next, carbons. 2 carbons, 1 carbon, so let me put a 2 there. I'm still fine with my O's. And at this point, I just need to do the math. I have an even number of oxygens, and my carbons are balanced at 2. My hydrogens are balanced at 4, so we're in the final stretch. 2 times 2 is 4 oxygens here, plus 2 more is 6, so 3. And going back, 1, 3, 2, 2 can't be simplified down, so that's the correct answer. Next one, P plus O2 yields P2O5. In this case, I'm kind of looking at evens and odds here. I'm seeing O2, so I'm always going to need an even number of O's. So looking at this, I'm going to put a 2 in front. That's going to give me an even number of O's, 10. All right, now in this case, I'm going to leave the P for last because it's kind of all by itself. Let me do the O2's now. So 2 times 5 is 10, but I have 2 here, so I'm going to put a 5 there. And now I'm just going to finish up with the phosphoruses. 2 times 2 is 4, so a 4 here. Okay. For this next one, another combustion reaction, C6H6. Well, let's see, H6, H2. So I would put a 3 here, but already I'm thinking, if I put a 3 there, that's going to give me an odd number of O's, which is going to be a problem. So when in doubt, double everything. So instead of putting a 3 here, I'm going to put a 6 there. And instead of a 1, I'm going to put a 2. Okay, so this should balance out my hydrogen. So let's see, H6 is times 2 is 12, 12. All right, now for my carbons, 2 times 6, so that's 12 as well. So let me put a 12 here. And now I just need to count my O's and balance it out. So 12 times 2 is 24, plus 6 more. 24 plus 6 is 30, so I need 30 O's. So I have O2 here, so I'm going to put 15. 2, 15, 12, 6 can't be simplified, so we're good. All right, next one. Let's see. I'm noticing SO4, that's sulfate, and I'm seeing SO4 sulfate here. So for this one, you want to keep that sulfate together. Don't break it down into S's and O's. So let's see. Bariums are balanced. Chlorines, I have 2 here and 1 here, so let me put a 2 there, and that should do it. H2, H2, SO4, SO4. So that's simple. Okay, for the next one, so similar type of problem. I'm seeing NO3 nitrate, and I'm seeing NO3 nitrate. So I'm going to keep those together. So 1 lead, 2 nitrates, 2 nitrates, 2 potassiums, 2 potassiums, 2 iodines, 2 iodines, we're balanced. Next, I see H2S plus AlOH3. There's my hydroxide. But you notice on the other side, I don't have hydroxide. No hydroxide. So what you should do instead, change the H2O to HOH. HOH. So now I'm looking at front hydrogens, aluminums, sulfurs, hydroxides. And this should be pretty simple to balance now. All right, well, for this one, I'm kind of already looking ahead, and I'm seeing 2s and 3s. 2s and 3s, 3s, 2s and 3s. When I see 2s and 3s, I'm kind of thinking evens and odds. I have a feeling I'm going to have to get all those into the same number, like 6 is what I'm thinking. So let me actually start with these 3 hydroxides. If I have 3 hydroxides, I'm going to go over here and do 3 hydroxides. So 3 hydroxides, but looking ahead already, that'll give me 3 hydrogens, and here I have 2 hydrogens. So notice it's kind of an evens and odds thing. So I was right, I am going to have to get these to 6. So when in doubt, double everything. So instead of calling this 3 hydroxides, I'm going to call this 6 hydroxides. So 6 hydroxides, and I need 6 hydroxides here. So let me put a 2 there. Okay, 2 aluminums, we're good. Now over here, 2 hydrogens and 6 hydrogens, so I'm going to need a 3 here, and that should fix my sulfurs too. 3 sulfurs, 3 sulfurs. So the numbers are 3, 2, 1, and 6. I'm now going to erase the HOH because that's not a good way to write water, it just helps you balance it. And now we're solved. Okay, and for the last one, let's see, so this is going to be a little trickier. You see we have 5 terms, so let's go through it. CuO plus NH3, N2, Cu, H2O. All right, so I'm kind of looking at evens and odds here. I see N2 and I see H2. So I'm thinking in my head, I'm going to need to have an even number of H's and N's for this to work. And I see NH3 here. So in order to turn the odd numbers here into even numbers, let me put a 2 there. So the 2 N's are balanced now. For the H3 times 2 is 6, so let me put a 3 there. And I'm kind of looking ahead. I have 3 O's. Is that going to be a problem? Well, no, because this O is only 1, so I can put a 3 there. Okay, and I'm already thinking I'm going to leave the Cu for last because it's alone. So let me put a 3 in front of there to balance my O's. And now I could just put a 3 in front of the Cu. So let me just, because this is a lot of steps, let's just double check. 3 coppers, 3 oxygens, 3 oxygens, 2 nitrogens, 6 hydrogens, 3, 2, 1, 3, 3, we're balanced. Okay?